What's up, guys? If you're watching this video, it's because you've been chosen to do the lesson one, where we'll be talking about factoring the square of a polynomials, and in this case, binomials. The polynomial will be binomials, or two terms. So let's break down a couple of these concepts. Square, something to be squared, like x squared. We're talking about this exponent right here being 2. When we're talking about squaring polynomials, we want to look at this guy in 3 features. That was 2, but that's 3. We want to look at this guy in 3 features. So we're going to look at it like this. Here's my binomial, or 2 terms, right? And we say this binomial squared, or this binomial squared, or whatever we have 2 terms and they're squared separately like this. These are the 3 ways that you will see squared polynomials in these upcoming lessons. So let's talk about what it means to square then. What it means to square something would be simply to multiply by itself. And here's a homework answer for your vocabulary. So again, square means to just multiply something by itself. So x squared simply means x times x. So let's look at this guy. We have first example right here is a plus b in parentheses squared. Well, square means to multiply something by itself. So all I'm doing is saying a times b times a times b. And this is why I draw it out like this. A times b in a parenthesis right there times a times b in a parenthesis right there. Now, we could solve this by distributing or using distributive properties. So the first thing I'm going to do is take this first term to the second term. Then I'm going to multiply this first term to the second term. Then here to here, then here to here. So first, a to b, a times a, a time to a, it's a times a squared. Then a to b, a times b, ab. And down here, b to a, b times a, ba, and then b times b, which is b squared. Now, I combine my like terms. And when we look at this guy, these are like terms right here. Even though this says AB and this says BA, we want to remember the commutative property, okay? Which says we can look at things or variables that are switched around. So these are like terms. So these are not like terms, these drop down. So A squared comes down, B squared comes down. AB plus BA is 2AB. Looking at this guy right here. Same. Take a minus b, multiply it by itself, use distributive property. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ba. And negative b times negative b is a positive. Negative times negative is a positive b squared. This is not a like term. This is not a like term. So both of them drop down here. Here are my like terms in the middle. Minus negative 1 minus 1. Is a negative 2, AB, okay? And then looking at this guy right here. Again, we solved this guy by focusing on this concept of the square root. And when we look at this guy, we understand that square roots have both positive and negative solutions to it. So a squared minus b squared. We want to square root this guy. And when we square root that guy, well, we make 2 parentheses basically down here. When we square root a squared, or 1a, well, the square root of 1 is 1, so 1 would appear in the front of both angles. When we square root a squared, well, that square cancels out, and this is why a is represented here. Same thing for b. Because we have a minus sign in the middle, remember the square root powers have both positive and negative values. So let's let's look at a couple examples. With numbers, example, we have open parentheses x plus 5 squared. Again, something squared, we multiply it by itself. So x plus 5 times x plus 5. And then we use the distributive property. X times x is x squared. X times 5 is 5x. 5 times x is 5x. 5 times 5 is 20. Combine my like terms. X squared is not a like term, it drops. 25 doesn't have a like term, it drops. 5x plus 5x is 10x. Here's my answer. You can use the foil method here, or you can use the tabular method here as learned, or you should have done it in the previous lessons. Let's look at a little bit more challenging one. We have in parentheses 3x plus 4 squared. Again, squared means to multiply something by itself. So 3x squared plus 4 times 3x squared plus 4 in parentheses look like this. We can use the foil method or distributive method. You can use distributive method, foil method, or tabular method right here. But let's use the distributive method just to, be simple. 3x times 3x is 9x squared. X times x is x squared. 3 times 3 is 9. 3x times 4 is 12x. 3 times 3 is 4. X to nothing is x drops down. Then I go here. 4 times 3x, again, 12x. 4 times 3 is 12. X to nothing is 12. And then the last but not least, 4 times 4, which is 16. 9x squared doesn't have a like term, so it drops. And 16 doesn't have a like term, so it drops. 12x plus 12x is 24x. Here's my answer. And last but not least, this guy right here that I know I did a horrible job explaining, let me give you a better example right here. So where it says a squared minus b squared, let's look at it like this. 4x squared minus negative 9y squared. So this is my b, this is my a over here. Okay, so we solve these guys by taking the square root of it. So I take this entire thing and I put it under a square root symbol. So the square root of 4 is going to give me 2. Then that square root cancels out the x, so my x drops. That's a minus sign, that's a minus sign. Okay, now the square root of 9 is 3. The square root cancels out that square for that y, so y drops down. Now remember, the square root has both a positive and a negative value. So I draw my parentheses, and with that number right there, that's going to have, that symbol is going to have a positive value and a negative value. So I keep the same terms and put it in parentheses. So 2x minus y, I put it right here, and then I need that same one to be positive for the square root, and it's a positive right there. And this is how you factor the square of a polynomial.